Ladies and gentlemen, before I start this presentation, I will introduce myself first. My name is Nurik Destriarianti from Department of Information System, University Technical, Malaysia, Makkah. Today, I will present my research with the title is Red Blood Cell Classification with Sharpening Segmentation and Mass RCNN on 14th International Conference on Subcomputing and Pattern Recognition. This study sample image taken from the American Society of Hematology image books. Introduction. Identifying and counting blood cell, red blood cell, white blood cell, and platelet is an important health indicator to know. Technology for identifying and counting the number of blood cells based on image processing as a non-invasive has been widely developed until now. The RBC classification might be prepared as a problem of pattern recognition. Objective: to classify red blood cell by applying sharpening segmentation combined with an RCNN mask. Material and methodology. There are two stages in the RBC segmentation process in this study. The first, in the sharpening process, which is process with three methods. When I analyzed previous research, the overlapping segmentation process did not carry out the sharpening process first. The sample image will be processed at the sharpening stage first using three methods, namely sharpening 1, CLHA, and also threshold. The second process is the overlapping RBC segmentation process using the mass RCNN method. The method is not a new method in the segmentation process. I use this method because, in my opinion, it is the most appropriate method. Because in the final result in this research, I will compare the result of the segmentation that went through the sharpening process first and without going through the sharpening process. Then we'll see the accuracy. And the last one is the evaluation and comparison of the result using the confusion-matic method. The dataset, namely RBC image, will go through the sharpening process with the one library. The one or magic one is one of the libraries in the Python programming language that starts to sharpen and provide texture sharpening to image. The use of this one helps clarify object in the image. After entering the sharpen process, the result from the process will be processed using the CLHA and also threshold method. CLHA is used to sharpen the color in the image. The base color will be sharper after going through the CLHA process. Also, it's used to cover the background has a color similar to the object. The result of this 3 process will produce an image that has been sharpened and noise has been removed so that the image has 3D for segmentation. Result and discussion. The primary objective of the image segmentation procedure to divide an image into a zone of homogeneous representation that correspond to the object of interest in the picture. The real success of a method for overlapping categories of RBC depend on its ability to segment the RBC area in the observed image properly. Proposed method perform exceptionally well with range and average accuracy of 55 until 97% and 81.4, more or less 10% respectively. On overlapping RBC, precision 23 until 100%, average of 61.2, more and less 22.5%, and recall 69 after 100%, average of 89.1, more or less 11.1%. On a single cell in RBC, precision 81 until 100%, average of 92.2, more or less 5.3%, and recall 53 until 100%, average of 87.9, more or less 10.2%. Almost all of the test image sample, the segmentation method using sharpening is superior to the one without sharpening proposed in the study. Classification with the sharpening method gives a better average accuracy of 17.4% compared to without sharpening. Conclusion. This paper proposed a framework to classifying RBC into single overlap and cluster. The system consists of a combination of three methods: sharpening with one library, contrast-limited adaptive histogram equalization, and also threshold. Classification with the sharpening method proposed in this study gives an average accuracy of 17.4% better than without sharpening. Future work from this study is to test the robustness of the classification model developed by applying big data RBC before this method can be used on the real world. Acknowledgement. This work was supported by fundamental research grant scheme from the Ministry of Higher Education, Malaysia. Thanks for attention.